What's wrong with it? Did anybody else have problems? I know you did. Did anybody else have problems with Adobe Scan?
No, mine's free. I need some money.
Take out your Chromebook and submit it that way so at least it's safe. We'll look at trying to fix that. You said it didn't submit? Oh, if it didn't. Oh, I got you. Yeah, you got to pull that Canvas app back up and look to see if it's submitted. All right, questions? Anything? Last call, 1 through 6. Going once? Yes. Number 4. Let's do number 4 together. Before I do number 4, tell me some things you know about number 4. It's a sad one. Why is it sad? What makes it sad? It's negative, so it's going down. It's a sad, sad parabola. What else do you know about number 4? The y-intercept is 8, and it doesn't have a b. B is 0. What else do you know? You know one more thing. Skinny or wide? Skinny because it's bigger than 1. So we're good to go to graph. Let's identify our A, B, and C. What is A? How about B? How about C? Look at y'all go. You are graphing professionals. What about a vertex? Opposite B over 2A. That's right. Plug it in. What do you get? 0 over. It doesn't matter what it's over as long as it's not 0, and it's not because it's just going to give me 0. How do I find the corresponding y part of that vertex? Plug it into that equation. That's right. So I got -4 times 0 squared plus 8, which is 8. Too fast or just right? Y'all okay? All right, good deal. So I go up to 8, and there is my vertex. In this case, I cannot use the y-intercept as my easy point because the y-intercept is my what? Vertex. So I need another easy point. So this is the time when y-intercept doesn't work for easy point. So easy point, I'm going to stay very close to that vertex. So what's very close to 0? 1. Plug in 1. That's exactly what I would have picked as well. When I plug it in, I get y equals -4 times 1 squared plus 8, which is 4. So that point is 1, 4, 1, and then 4. We'll call that 4. Reflect and connect. Remember, this vertex is also my axis of symmetry. So I reflect over that axis over here. Is it sad? Yes. Is it skinnier than average? You can't tell on mine because I'm not very accurate, but it would be yes. So it does all the things it's supposed to do. What, that you understood? Oh, and you take it back now? Okay. I'll remember that whenever I look. Okay. That's okay. That's all right. I forgive you, Leah. Okay. Anything else? Everybody okay? Oh my. Step by. On number 6, you are going to be able to use the y-intercept as the easy point. So let's see. All right, what's A? B? C? Tell me what you know just so we can check as we go. Up, happy parabola. Close. Skinny. It does the opposite. Remember, it's hard. It gets real confusing, but it get skinnier. What about the y-intercept? -5. All right, let's graph it. So for my vertex, opposite B over 2A, right? Opposite B is 2 over 2. I see right now why y'all didn't like this one. So 2 over 4, which is 1/2. And then y'all went, I'm not doing a stupid fraction. And you just, oh, y'all didn't get a fraction?
I got 4 over 2. Nah, I got 1. And I don't know how.
Then you probably got something. Let me show you. It's a little early right now for a little calculator trick. Well, it's never too early for calculator. If you already have your calculator, take out your calculator and let me show you a little trick. I don't have my document cam set up just yet, but I'll get it set up so I can show you up here. If you don't have it yet, it's okay. But here's what I want you to do. Do we all agree that we're plugging 1/2 in for the x's here to find y? All right. Here's what I want you to do. I want you in your calculator. Now here's a trick. Fractions always go in parentheses on your calculator. Do we know that? Okay. I want you to do parentheses 1 divided by 2. Close parentheses. And then there's a little button. It's right above the button that says on, and it says STO. Okay? I want you to push that button that says store this value, and then I want you to click the X button. Do you know the button right beside the green alpha for X? See the green alpha button? Look right beside it where it says X, theta, T, all those variables. Click that button and hit enter. Okay. Now, every time you type an X, it's going to let the X be 1/2. Okay. So what you can do is you can do on your calculator, you can put 2, hit the X button, squared, minus 2, hit the X button again, minus 5. And you can literally type that equation in just like that. And your calculator knows that every time you have an X, it's putting this in place of the X for you. So what do you get when you do that? -6? -5. I got -5.5 and -6. -5.5. Let me show you another little trick too, and we will practice with this a lot. Now hit math, enter, enter. Did you not know that? Oh, you did know that. Man, you are your father's child, and I fall for it every time. Okay. I don't think so in here, but I have to know how it is. All right, whether you did it with the calculator on stove or whether you did it by hand, it doesn't matter. You should have come back to -5.5 regardless. Does everybody get 5.5, -5.5? All right. So that means my vertex is 1/2 -5.5 or negative, what, 11/2? 1, 2. So I'm going to go 1/2 -5.5 and put it there. That's my vertex. So it should be opening up. I can use my y-intercept this time because it's not the vertex, right? And it's right beside us. It's -5. And then, of course, I'm going to reflect and connect. Everybody okay? All right. Anything else from your homework? Going once, twice. So we graph lines in all these different forms, right? We got standard form, slope intercept, point slope. The same is true about parabolas and quadratics. We have all these different forms. Bless you. 3 really that we graph from. The first is standard, is the hardest, so we spent a whole day on that. The next 2 are a lot easier than standard because there's a lot fewer steps than the others. So let's just jump right in, I think. So vertex form is gonna look like this. all three of these forms, the A does exactly the same thing. It tells us up or down. It tells us skinny, wide. I'm not going to go through all of that because we did that on Friday. Remember, positives up, negatives down. The bigger A gets, the skinnier the graph gets, the smaller, the wider, right? The difference in this form and the others is this time, as the name implies, it gives us the vertex. Okay? So for this form, if I take the H and the K, I will have the vertex. And in my opinion, that's the hardest part about graphing in standard form because we have to plug in that little opposite B over 2A, and then we got to plug it back into the equation. That's all taken care of for us in vertex form, okay? The only thing you have to be careful of is because this original formula has a minus, that tells us that H is going to be the opposite sign and K is going to be the same sign. So I'm going to give you a couple examples and see if you can follow with me what I'm trying to say. Looking at the example there on the bottom, 1/2 x plus 1 squared minus 3. What do you think the vertex would be here? Close. -1, -3. Remember that opposite sign here? Whatever's here, make it opposite, okay? Sorry. Wait. Okay. Wait a minute. You really do have to slow me down sometimes. I told you I get excited and I just, okay, sorry. Good. Is this one skinny or wide? Wide. Why is it wide? 1/2 is smaller than 1, so it's definitely widening up. Is it up or down? Up, right, because it's positive. No, you're good. Y-intercept. Trick question, you don't know because it's not standard form. Okay. Moving right along. You don't know the y-intercept on this one because unless I plug the 0 in for x, right? It's a different form, so it does not give you that y-intercept. Y'all will get used to me eventually, I promise. I apologize in the meantime. One more. That's how you find the vertex. Now, we're going to graph it in just a second. I just want to make sure that you can recognize the vertex in the equation, and then we'll get into graphing it. While you copy it, up or down? Down, baby. No, I'm just kidding. Okay. Skinny or wide? Skinny. What's the vertex? 7, 0. Nice. Yeah, I tried to throw you off. Didn't work. All right, everybody okay on how to identify the vertex in vertex form? All right, then let's move right along. Okay. Sorry. Did you like the steps or not? The steps an example or not? Yeah. Everybody, can I scroll? How to. All right, let's do steps. Example. There's vertex form. I think I'll do the example that's just on the back here. It's a nice fraction for us. Oh, no, waiting on y'all to. Yeah, it's the one on the back of vertex form. Bless you. Bless you. Bless you. Can you go back up? Gracie, is that working with your computer in front of you like that? With the okay. You can also scroll as you need if you need to go back or anything like that. Welcome. Forever. And I do a new one each day so you don't get confused. So yeah, you can still go back and get it. They're all active. The notes board. No, like here, like the notes here. No, like if you go to Canvas, it says Notes Standard Form. That'll take you to the Miro board for that day. Yeah. Ready? Everybody caught up? Okay. First things first. Whoa. Plot the vertex, and we know that the vertex is just HK, but we have to remember what about H? Opposite sign. So over here, what is the vertex for my example? Close. -2, 5. So all that work we did at the beginning in standard form, gone. We don't have to do that here. This is my favorite form to graph in. The what? Oh, sorry. I'm going to go ahead and plot -2, 1, 2, 3, 4, and 5. Remember, this is also my axis of symmetry, yes? All right. Now I pick back up with all the other steps, except I can't use a y-intercept for my easy point. I can't use a y-intercept. Why? It doesn't give me, well, it probably exists, but it's going to be harder to find, right? So I can't just pull it from the equation. So in this case, and this is why I said I feel like easy point will start coming together for you as we do these other forms. What I want to do is I want to stick really close. I'm going to put EP. If you don't know what that means, write easy point in your notes. But what I want to do is I want to stick really close to the vertex. So what I tell students usually to do is maybe take this H with the opposite sign and add 1 to it so you're right beside it. So in the case of my example, what's a good X to use? -1, because if I add 1, here, right, I get -1. Do y'all see where that's coming from? Same place it comes from in standard form. Just add 1 to the vertex there. Okay. All right. How do I find the corresponding y value? You plug it in. So this is going to be -1/2, -1 plus 2 squared plus 5. -1 plus 2 is 1. 1 squared is 1. Times -1/2 is -1/2. I got 4.5 for that one. So that means the coordinates of that easy point are going to be -1, 4.5. Okay. Yes. Yes. Yep. The last step is the same as standard. What is it? It's my favorite. Reflect and connect. What's supposed to be a negative? Oh, I was just pointing to that. It shouldn't be there. There you go. I'm going to reflect over 1, and then connect. Tell me what you think about vertex form. You like it? I like it too. It's easier. Okay. You don't know yet? Yes. You sure? Yeah. All right, I want you to take 2 minutes, and I want you to try one, and then we're going to come together and do it together. It's actually example 2 on the back of your notes. Yeah, sorry. What about the vertex? What's the vertex here? 3, -2. Beautiful. Make sure you change that sign on the H. So now I have 1, 2, 3, 1, 2. My vertex, which also gives me my axis of symmetry, which is going to be that line over which I reflect. Give me an easy point. What'd you use for the X easy point? 4. How did you get 4? Where did that come from? Plus 1 on the X. 3 plus 1 is 4. That's what I'm going to use to plug in. Now, is it wrong if you chose 7? No, you can choose whatever you want. We call it an easy point because it's the one that makes it the easiest for us to work with, okay? 48. You could choose 48 if you like, yes. You're going to be way off the graph. Yeah. Oh, you got 48. Yeah, that's probably not right either. All right, so a couple questions about how I simplify this. Make sure you're going order of operations. Do the parentheses first, which is 4 minus 3, which is 1. And in fact, if you stay 1 beside the vertex, you should always get 1 inside that parenthesis there, which makes life so much easier because 1 squared is 1, 2 times 1 is 2, and 2 minus 2 is a big fat goose egg. So 4, 0, and now, of course, just reflect. How many of you got that one right? Yay! Give yourself a pat on the back. If you didn't, it's okay. We're going to keep practicing. Good job. Thanks, Leah. Appreciate it. All right. Switch your Rooney. Let's go to the next form. This is the one students make the most mistakes on. You would think it would be standard form, but here I have found students make the most mistakes because they get confused on what is what in this equation and what it is you're finding. The name itself tells you what the equation is giving you. So it says intercept form, so it's giving us the intercept. And in this case, it's going to give us the x-intercepts, not the y-intercept, okay? Which means I could potentially have how many? If you think about the way a parabola is. 2, right? I could potentially have 2 intercepts. So that's why intercept form is kind of handy. So here's what it looks like. Did you say wait? Did you say wait? Okay. X minus, we're going to use some different variables this time because they're giving us 2 different things. Notice the A that is still there. The A is our friend. The A tells us so much information, and lucky for us, it's in every single form. Same thing. Tell me what it tells you. Y skinny. What else? Up or down? Happy or sad? Same thing. Same thing it told us in the other 2 forms is the same thing that it tells us here. So I can still get a lot of information just looking at A. Now, this time it gives us the x-intercepts. And so these 2 are my 2 x-intercepts. But again, notice these minus signs here? Just like in vertex form, I need to make them opposite signs. Opposite, opposite. Those are my intercept. We will spend the whole rest of this chapter learning about why and how to find them, but for right now, all you need to know is those are your x-intercepts. Opposite signs there for both of them. Yep. Yes. So if you look at my equation here on the bottom, have y'all finished with this top part? This is an example. Tell me what you know before you look at intercepts. It's happy, it's opening up, and skinny, right? Everybody okay with that? All right, now I also know that my x-intercepts, which means where it's crossing the x-axis, are what? +1 and -5. That means no matter what else this graph is doing, at 1 and 5 and opening up, right, it's doing this. I don't know the vertex yet. I'm going to show you how to find that in just a second. But that is what I know. Is anybody confused on how to find the intercepts and intercept form? I know this is a lot, and I'm fixing to stop because I've reached your maximum capacity yet. So those two intercepts are where it crosses the x-axis, and because it opens up, I know that this is what it's going to look like. But I'm fixing to show you how to find the vertex, so we'll be a little more precise with it than just that. Yeah. Well, the reason they make mistakes on this is they'll look at this equation and they'll try to plot the point 1, -5 and call that the vertex, and then they'll get mixed up. So realize that it's two different points here. Here's a little trick I use to remember. I was going to tell you this later, but I might as well because it's relevant. This has one set of parentheses, so it gives us 1 point. This one has 2 sets of parentheses, so it gives us 2 points. The number of parentheses in the problem tells you how many points that it gives you, and that'll kind of help you remember which is which. Yeah. Good catch, Miles. I did. Great day. I'm getting too excited too fast. All right, let's see. I did. I wrote -5, but I plotted +5. So now, no matter what else it's doing, is something like that. Thank you very much. Thank you for not letting me go through the whole problem again this time with it wrong and stopping me before I got to that point. If you're writing in pen, I apologize. Are you? I'm sorry. All right. So how are we going to graph? Let's do our steps. I'll give you a second to copy it. We'll do it together. All right. You ready? Still copying? Yes, no? All right. First things first. we're going to plot the x-intercepts. Remember opposite signs, so x equals p and x equals q. And I'm going to put a little note here, opposite signs. So looking at the example, what are my x-intercepts? That's right. Don't plot this as one point. This is two different points, right? This is where it crosses the x-axis. So -3 and +1. Now here's where we have to kind of stop and think for just a minute. Tell me what, I need 3 points to graph any parabola. I have 2 of them. What am I missing? The vertex, right? That very, very important point. Thinking about what you know about parabolas, tell me what you think you might be able to do. Go like this. So what are you finding? Because you're exactly right. The middle. You're finding the middle, the axis of symmetry. That's exactly right. So now I'm going to make you really think for just a minute. These are nice whole numbers, but maybe you don't get nice whole numbers every single time. How do you find exactly in the middle of any 2 numbers I give you? You're exactly right. Well, how smart y'all are. So to find the vertex, you are on it. You got it. I'm going to, oh man, I forgot I already handed that to y'all. Dadgummit. Okay, so I'm going to add P and Q together and I'm going to divide by 2. Still with the same opposite signs that I used before. Okay, so looking over here in my example, I'm going to do -3 plus 1 divided by 2. -2 over 2, which is, okay, that is my axis of symmetry. Yes? How do I find the y part of my vertex now that I have the x? You plug it in. That's the same thing in all 3 forms. Plug it in. Plug it in, plug it in. Guess who taught me that? Miss Redfern. She used to sing plug it in all the time. Plug it in, plug it in. Okay, so I'm going to do y equals 2 times, or plug and chug. Yes, she used to say that all the time. Be very careful with all these parentheses. They very well can, or they can throw you off. -1 plus 3 is 2. -1 minus -1 is +2 as well. 2 times 2 times 2 is, oh no, wait.
-1. When you plugged in -1, -1 minus 1. You put so many negatives.
Wait.
No, it's just -1. Negative.
This is -2. Sorry. Because it's just -1, yeah. But do you see what stopped me? Do you see how I knew I'd done something wrong? When I got to that last step, I said 2 times 2 times 2 is 8. 8's up here. That's going to make my parabola go down. It's not supposed to go down. It's a happy parabola. It's supposed to go up. And that's how I knew I had a sign error. So see, I did that on purpose to make sure y'all were following. So -8. I start rushing and get in a hurry because I get so excited. All right, so we're going to say this goes down to 8. It should go through the points. There's no reflect and connect because you had your 2 points to start with. Remember, you had your 2 reflected points initially. We just found in the middle. All right. I don't like the example that's on here so much, so I'm going to give you one more example. And I want you to try this one. Yeah. Yeah. Um, Tell me what the x-intercepts are. Yes, -1 and 3. All right, now I need to find exactly in the middle. This was easy. You could technically count until you get exactly to the middle. But I'm going to go by the formula that we had, and I'm going to say that I need to add and divide by 2, just so I show you that it works. So 2 divided by 2 is, of course, 1. So there's my axis of symmetry. How do I find where on this axis it occurs? Plug it in. That's exactly right. So I'm going to have -1/2 times 1 plus 1 times 1 minus 3, which would be -1/2 times 2 times -2. Two negatives make a positive, and I get +2. Whoop. It opens down as it should. It has definitely widened up from a normal, so I am spot on. Does anyone have any questions, comments, concerns? Yes, ma'am. I'm gonna tell you which ones I want you to do. I'm gonna tell you.